Today we're learning about the addition property of equality. For most of you, this should be a review from pre-algebra. I know I've got this when I can define linear equations and use the addition property of equality to solve linear equations and write word phrases as algebraic expressions. Key vocabulary is solving an equation, linear equation in one variable, equivalent equations, and addition property of equality. So a linear equation in one variable involves variables that are raised to the first power. Examples of linear equations in one variable are listed below. So you'll notice in all of these, they only have one variable, and it doesn't matter if it's x, y, or c. They only have one variable, and that variable is only raised to the first power. So solve each equation. Okay, so I'm just going to add 6 to both sides. So since I have y minus 6, I would do the inverse operation. The opposite of subtraction is addition. So y equals 24. Okay, I'm trying to isolate the t here. So if I want to get the t by itself, I would have to add 5 to both sides of the equation. That cancels. Negative 18 plus 5 is negative 13. And that would be my answer. Okay, now you're going to do this one. So I know it deals with fractions, but I have confidence that you can do it. Go ahead and pause and try to work it out. Okay, now we're going to do it together. So I've got minus 2 thirds. I don't know what that was. So this cancels out. You know, anytime you have to subtract fractions that you're going to get a common denominator. So the common denominator would be 12. So this would be negative 9/12. Okay, so 3 times what gives me 12? 4. So 4 times 2 is 8. This is how I'm getting this. So negative 9 minus 8 is negative 17 over 12. So that is what you should have gotten for your answer. All right. So solve each equation if possible. Be sure to simplify each side of the equation. So, okay, in A, we're going to have to distribute. So I'm going to distribute this 5. So I get 5y plus 10 equals 6y minus 18. Now, I need to get my y's together, okay? So I always want to try to keep a positive variable if I can. So I'm going to subtract the 5y. When I do, I get 10 equals 1y minus 18. Then I need to isolate the y, so add 18 to both sides of the equation, and you get y equals 28. Okay. Now, next, B, we have, in that one, I'll write it up here. We got y equals 28 for A. Okay, in B, let's combine like terms before we start moving stuff to the other side of the equation. So I've got negative 8z plus 6z, which would be negative 2z plus 5 equals negative 3z plus 10. So I'm going to, in this case, I'm going to add the 3z to both sides so that, again, I can have a positive variable. So I get 1z plus 5 equals 10. Oh, by the way, my z's have lines, just in case you didn't know that already. Subtract 5 from both sides, and I get z equals 5. All right. So now we have a lot of fractions. Now, I don't know about you and how you feel about fractions, but most students do not like to use fractions. So here's something you can do. You don't have to, but you can multiply the whole equation by the least common denominator, which I would suggest, which is, okay, our denominators are 6, 3, and 2, so the least common denominator is 6. So if I distributed a 6 to everything, 6 times negative 1, 6 is negative 1. 6 times negative 1/3 is negative 2. 6 times 5, 6 is 5. And 6 times 1/2 is 3. All right, now you are going to combine like terms. So I'm going to add the 1x. to both sides, and I would get -2 equals 6x plus 3. Okay, so I need to isolate the x, so I'm going to subtract 3 from both sides of the equation and get -5 equals 6x. I still need to isolate the x, so I'm going to divide that 6, and I would get x equals -5/6. Okay. D says, all right, 10x equals 4x plus 9 plus 5x. So again, I'm going to combine like terms on the same side of the equation first. So I get 10x equals 4x plus 5x is 9x plus 9. I'm going to subtract 9x from both sides. Now I get x equals 9. All right, I'm going to give you a second to let you do this one. Go ahead and pause it. And the answers are -17 and 24.2. Okay, so again, here's some more words to use when writing algebraic expressions. You can pause it and look at these or write them down. All right, number 3A, two numbers have a sum of 72. If one number is z, express the other number in terms of z. Okay, so two numbers have a sum of 72. So z plus something equals 72, right? And it says if one number is z, write the other number in terms of z. So we're trying to get this question mark number by itself. So how would I do that? If I'm adding this z, I would subtract the z from both sides. So my question mark number that we don't know can be written as 72 minus z. All right, on a recent car trip, Raymond drove X miles on one day. On day 2, he drove 170 miles more than he did on day 1. How many miles in terms of X did he drive for both days combined? Okay, so on the first day, he drove X days. On day 2, so this is day 1. On day 2, he drove 170 miles more than he did on day 1. So day 1 plus 170 more miles. How many miles in terms of X did he drive for both days? So we're just going to combine these, and I would get 2x plus 170. During a recent marathon, Tom ran 8 more miles than Judy ran. If Judy ran 8 miles, how many miles did Tom run? Okay, so Judy ran X miles. Tom ran 8 more than her. So that is how many Tom ran. So I know I've got this when I can define linear equations and use the addition property of equality to solve linear equations and write word phrases as algebraic expressions. And that is it.